Okay, g'day students. Welcome to our lesson on X-ray crystallography. So basically we want you just to be able to select and use data from X-ray crystallography to help determine the structure of organic molecules today. Now we don't need to analyze any of the data, so the second criteria says nothing about X-ray crystallography, so that's nice. But let's look at X-ray crystallography and what's happening here. So the technique is used to determine the three-dimensional structure of large molecules, for example, DNA, enzymes, and viruses. Now the techniques measure the angles and the intensity of X-ray beams or diffracted X-ray beams, and that's used to determine the position of the atoms in a crystal. Now computers then analyze the diffraction pattern to create an electron density map, which is a result of the atom's position in the crystal. Now there are some factors that affect this diffraction pattern. First of all, the photon wavelength. It's got to be about the same distance as between the atoms. So X-rays fit that distance, and that's 10 to the negative 10 meters, comparable to the distance between atoms. The crystal size. Now the crystal needs to be thin enough to be transparent to shoot X-rays through it. But it needs to be thick enough to produce multiple images. The crystal quality shouldn't have any cracks or flaws in the crystals, otherwise you might get a poor diffraction. And if the samples actually vibrate, that's also going to create a poor picture as well. So you can see when placed directly underneath the scanner, if the sample's constantly moving and the X-rays are therefore constantly being diffracted, and you're going to come up with a picture that looks a bit like this. So I think we all get that hydrogen's got one electron, and if we have a look at the electron density map here for hydrogen, for example, we would expect in a molecule that the electron should be hanging around in two distinct places around the outside of a nucleus. Now these electron density maps will be able to construct some really beautiful pictures, won't they? And we'll be able to get an idea of the structure of the molecule. And we can have a look at a few different places, but after having a look at the research, it's quite interesting the shapes that you can get with the shape of the proteins. Looking up in the top right hand corner, what can we see? We've got a molecule here with 4 carbons. It's got 1 nitrogen and 5 hydrogen. So what you can see here is that the nitrogen certainly is scattering the electrons a little bit differently to the way the carbons are. So let's have a look at an electron density map. So we've got a molecule called iron phthalocyanine. So it has the molecular structure of C32, H16, and 8. And this is the electron density map of the blue dimetal phthalocyanine. It's as a crystal, so we want to determine the structure of the organic molecule. So we want to think what's being scattered most, and you can see that there are different regions of scattering. So first of all, you can kind of see, well, this is being scattered in a particular way. Next of all, you can see a bit more scattering here. And then next you can see a different amount of scattering here. So we can determine, well, there's probably 3 different sorts of atoms in this crystal. So we can tell them apart. The one with the most scattering should be the metal. It's got the most electrons. It should scatter the X-rays the most. The next one will be nitrogen. Nitrogen's got more electrons, 1 more electron than carbon, so it will scatter the X-rays a little bit more. And then finally, carbon's got the least X-rays, so they'll be a little bit more spread out, and so that's the carbon crystals with the wider spacings. What do we need to think about? Hydrogen is probably too small to be seen as well. So carbon, oxygen, nitrogen, and metals should be able to be seen. The metals will scatter the X-rays most effectively, and nitrogen will scatter more X-rays than carbon because it's got 1 more electron. Got a couple of interesting pictures. So this is from the protein data bank, and you can see that the molecule down there in yellow. So you can just type that in and have a look. Here's another one, and this one is still in the protein data bank but with a different view, and that's iron phthalocyanine, and you can see there it is right in the middle. I typed in phthalocyanine into MoldView as well. You can see that structure of the crystal quite nicely reflects that. So are you able just to select and use data from X-ray crystallography to determine the structure of organic molecules? When you are happy with that, please move on to the mastery questions.